Hi Algebra 1 students, this is Miss Graham, and today we are going to be looking at 17.1, the elimination method. So our learning targets for today are going to be using the elimination method to solve a system of linear equations. We're going to really focus on that learning target for today. So let's go ahead and keep reading below and see what elimination is. So elimination is another algebraic method that may be used to solve a system of equations. We already learned two previous methods, graphing and substitution. This is our third method. So two equations can be combined to yield a third equation that is also true. The elimination method creates like terms that add to zero. So if we look over into the margin at the right, it tells us a little bit more about the elimination method. We can also call it linear combinations method, because what we end up doing is taking our linear equations and combining them together. Now you're probably wondering, why is it called elimination method, right? We're solving a system of two linear equations, but the key word is that we are going to eliminate a variable. That's why it's called elimination. So it goes through below what we're actually going to do. Let's read about it, and then we're going to start practicing it. So it says to eliminate one variable. What we're going to do is we're going to multiply each equation in the system by an appropriate number so that the terms for one of the variables will combine to zero when the equations are added. Our goal here with elimination is we either want to eliminate x or y so that we can solve for the other variable. So before we look at example A, what we're going to do is we're going to do a couple of examples in the margin below. So go ahead and find some space down below for us to work. You can also get another sheet of paper, or if you want to open up a new slide on Notability, find some space for some room. So let's go ahead and we're going to start with example number 1. So we're going to be given a system. So let's say we have x plus 3y equals -2. That's our first equation. And then our second equation will be 2x minus 3y equals 5. Now, in this case, you're probably already thinking, okay, would it be best to solve it by graphing, substitution? What's the best way? Right now we can see it's not in slope-intercept form. I could do substitution where I isolate a variable. That's fine. But we're going to have a new approach. We're going to have this way called elimination. So with elimination, what you want to first do is you want to set up the equations so they are written where we have our x's, our y's, and our constants all vertically lined up and down beneath each other. So sometimes we like to have the x and the y on the same side. Sometimes we like to have the number on the same side, because our goal is to eliminate one of these variables. So we're left with, let's say, x or y, and then our number on the other side, and it's easier to solve. So sometimes to do this, I like to put kind of some vertical lines. I like to draw that to just kind of separate each of our three sections. You can do that to help you out too. But what our ultimate goal is to add these equations together. So we want to add them together, add downward, and see what happens. I specifically picked this first problem because there's going to be some magic that happens. So let's go ahead and start adding each of these downward. So we have x plus 2x. That's going to be 3x. Whoa, look what happens when we do 3y plus -3y. Oh my goodness. You can see they actually cancel out. They eliminate. That's the purpose behind this. We want them to eliminate. So we have nothing there, so we can put our equal sign. And then when we vertically add -2 and 5, what do we get? Oh, we get a +3. This is our new rewritten equation after we added the two equations together. We can do that. So now let's figure out, how do we solve for x? Well, this is easy. We can divide by 3 on both sides, so that way we get x equals 1. I know, you're probably thinking, wait, that was pretty easy to do. I know, right? Now, the second step is going to be a little bit of the trickier part, where we have to solve for the other variable. A lot of the times we already had the other equations rewritten in a nice format where, maybe y was already by itself. What we have to do now is we're going to plug x back in to one of these equations, and it doesn't matter which one. You can pick the first, the second one, doesn't matter. I'm going to pick the first one. but we're going to go ahead and plug 1 in for x. So let me go ahead and I'm going to make this a different color so that way you can see that it stands out. So we are going to plug in 1 for x, and then we're going to put 1 plus 3y equals negative 2. And now we can solve for y. So best way to solve for y is subtracting 1, subtracting 1. All right, what do we end up getting? We get 3y equals negative 3. And then last but not least, we can divide by 3 to both sides. So lo and behold, we have y as negative 1. Look at that. So we were able to find a solution. So I always like to write a solution line, and I like to write my x and y as an ordered pair. Remember, your x value comes first, then your y value. So that's our solution, but let's just check to make sure that works. So we're going to check with both of our original equations to see if we input 1 for x, negative 1 for y, that we get both sides of our equation balancing, right? I always like to call it, you check so you can balance, your checks and balances. So let's go ahead, let's write down our 2 original equations. And what I'm going to do is I'm going to input 1 and negative 1 into their correct spot. So sometimes I like using a little bit of a different color so that way it stands out a little bit. So I'll put in 1 for x. Ooh, that's a highlighter. Let's try again. So I'll put in 1 for x, and I will put in negative 1 for y. I like to kind of space these out, and then I like to rewrite what the problem is. So don't forget that our first equation, we have to make sure we're multiplying that 3 times that negative 1. So it's 1, essentially 1 minus 3, and we're checking to see if that equals negative 2. Well, lo and behold, that does equal negative 2. And then our second equation, it's 2 times 1 minus 3 times a negative 1. So we end up getting 2 plus 3. Does that equal 5? Yeah, 5 equals 5. So that's looking good so far. So both of them check out, so we know that's going to be our solution. So there you go. We found our solution of 1, negative 1 for that system through elimination. So now we're going to go ahead and try another example. For my purposes, I'm going to erase the example that we currently did so I have a little bit of room to work with. Alrighty, let's go ahead and we're going to start on example number 2. So let's go ahead and write this one down. So we start with negative 4x plus y equals negative 9. And then we have 2x minus 5y equals 27. Now if we start off this problem and start kind of dividing it up into sections, and we see we're going to add downward, what you notice is different from the last problem, right? No variables cancel out. Uh-oh, that's kind of tricky here. What can we do about that? Well, we're going to have a little bit of an extra step. What we're going to have to do is figure out how to change one of these variables so they eliminate with each other. Now, we can't just magically change one of the variables. We have to kind of change the whole equation to reflect that. So when we're doing elimination, we can choose to either eliminate x or y in this situation. For our last problem, it was pretty easy to just add the equations without doing anything else to see a variable eliminate. But this time, we can choose either one. Now, for this purpose, we were able to eliminate y before. Let's try eliminating x. So that's going to be my focus. My goal will be, how can I eliminate x? Well, right now, I know if I added a negative 4 plus 2, that's not going to cancel out. So think about this. I have a negative 4x. What would be nice to be right here to add to negative 4x so it cancel it out? So think of what number would be nice to have right there. You're right. Number 4 would be nice to have there. So what we're going to do to try to get a goal of 4x is that we are going to multiply. That's right. We are going to multiply our second equation by 2. So we're going to multiply by 2. So when I say that, that means we're taking this whole entire equation of 2x minus 5y equals 27, and we're multiplying the whole entire thing by 2. So every single term. So we're multiplying the first term the second term. We're even multiplying the term on the other side of our equal sign. So we're rewriting the second equation to be a new one. So looking at this, we can see we end up getting 4x minus 10y equals 54. And what we'll do is we will replace our second equation with this new equation. So let's go ahead. We're going to write our original equation as is. So negative 4x plus y equals negative 9. And then we're going to write our new equation of 4x minus 10y equals 54. Now, remember, the reason that we can actually multiply our whole equation by this is that multiplication property of equality. Remember, when we multiply everything on both sides by the same number, it still holds the equal sign to be true, right? That's why it's called the property of equality, because when we do that action both sides of our equation, it still holds true. So now, like before, let's go ahead. We're kind of going to separate into columns like this, right? And we can go ahead and we're going to add together. We're going to add downwards. So let's start combining the like terms. So x's end up canceling. Yay! All right. Our y is negative 10y and a positive 1y. Ooh, that's negative 9y. All right, and we're going to set that equal to, well, 54 minus 9. That's going to be a 45. So now, to solve for y, we divide by negative 9. Divide by negative 9. And we end up getting y, oop, missed that negative 9, y equals a negative 5. So that's our y value. Yay! Now, what we can do is we can plug it back into either original equation. And in fact, if you wanted to plug it into the new one that you came up with, you could. I mean, it seems a little bit more complicated. So let's try to find the simplest one. So in this case, it actually doesn't really matter. Either are fine to work with. Let's just choose the first equation to plug this back into. So we're going to take negative 4x plus y equals negative 9. And make sure you're plugging in negative 5 for y, not x. First time I did this, I actually plugged it in for x. So be cautious with that. All right, so it's negative 4x minus 5 equals negative 9. Then we can go ahead and add 5 to both sides. So it's negative 4x equals negative 4. And then we divide by negative 4. So that way x equals 1. So we know our solution is going to be 1 and negative 5. Now, for time purposes, I'm not going to go ahead and check this, but if you would like to do that on your own time, you can check to see if it is correct. It ends up being correct. Spoiler alert. All right, so now is the time where we can start to look at the example the textbook gave. So let's zoom out a little bit. All right, so they start looking at example A. So they want us to solve this problem using the elimination method. So looking at this, we can see all our variables are lined up vertically. We can see when we would add our x's and our y's together that neither of those variables cancels. But what's hard is that, I can't just, like our other problem, I could just multiply one of the equations to get the other number. There's nothing, simple. I mean, maybe it's a fraction, but we don't want to make it too complicated. There's nothing I can really multiply 3 by to get 4 or 4 by to get 3. Same goes with the y's. I can't multiply 4 by anything nice to get 5 and 5 by anything nice to get 4. So we have to do something a little bit different. What we're going to end up doing is multiplying both equations. I know, right? So what they first start to do is to solve the system of equations by elimination, they decide which variable to eliminate. So for them, they decided to eliminate the y variable. That's because they already started to notice that they are opposite signs already. We don't have to change them at all whatsoever. So looking at this, what they thought was, okay, I know I'm going to have to get the y's to cancel out, but I'm going to have to multiply both equations by something. Now, if I multiply the first equation by 2, I could get this to be 10, but I can't multiply 4 by a really nice number to get 10. So we kind of have to think of common numbers that are going to be divisible by 5 and 4. So not 10, not 15, not 12, not 16. How about 20? what if I wanted this to be a negative 20y and this to be a positive 20y? So that's kind of what they set a goal as. They take this original system here and they think about how they want to cancel out the y's. So they multiply the first equation by 4. Now remember, when they multiply by 4, they multiply every single piece, right? They know that they're going to distribute that 4 to rewrite that. Oop, I moved the 4s. Let's try that. There we go. So for the second equation, they decided to multiply by 5, right? And it's not just to one side, it's to both sides. And they have to rewrite that equation too, using that distributive property, that multiplication property, where we can see, 4 times 4 gives us 16. 4 times a negative 5 gives us that negative 20, right? So we have that negative 20y. And then 4 times 30 is 120. We do the same thing for the second equation. So now, right, our goal, yeah, buddy, we got both of those being 20y. One's a positive, one's a negative. So guess what? Now's where we add downward, right? We kind of section off our pieces. We add downward. Boom, we get 31x. Boom, the y's cancel out. Oh, yeah, our constants are now 155. And then look at that. They then decided to divide by 31. I'm showing that work just in case you didn't see it. And they got x. So now this next piece, right? I mean, it's step 2. That's a huge step 1, multiplying both equations, but they were able to find what x is and then substitute it back into one of the original equations. Again, you could also do your rewritten equations, the ones that are multiples of the other ones, but I just like to keep it simple. So they went ahead and did that in step 2, and they were able to find out what y was right here, and then they did their check. Now, for check, I always recommend with the check, you want to check both equations. I know they may have only done one here, but I know for my students, I always say check both equations to make sure that they balance, right? Like checks and balances. So in the end, after the check, they see, hey, they still got a solution of 5, negative 2. So we're going to try one of those problems right now. So let's go ahead. Let's find some space of what's going on. I'm going to find some space probably below here. Yeah, that sounds good because guess what? We're going to be doing these problems together. I know, right? Okay, cool. All right, so let's start looking at A, and then, I don't know, maybe I'll have you do B as well. So let's start looking at A. All right, so let's figure out what we want to eliminate. I mean, we could easily eliminate the x's for sure, even though they're both positive, but sometimes it's easier to eliminate the y's. So go ahead, pause the video right here. I'm going to see if you can figure out what numbers we can multiply each of these equations by, so that way our y's would cancel. All right, so for me, I saw I would multiply my top equation by 5, and I'd multiply my bottom equation by 2. Now, again, we don't have to make this 10y. I could make it 20y. I could make it 30y. I just always try to choose the lowest number possible. And I know the lowest number that 2 and 5 both multiply into is 10. So let's go ahead and rewrite our equations. So that way we have 15x minus 10y equals 5 times a negative 21 is a negative 105. And then let's go ahead and rewrite the second one. So it's going to be 4x plus 10y equals 10. All right, I want you to pause the video right here, and I want you to see if you can add these two equations together and figure out how to solve for one of the variables. All right, did you end up getting x is negative 5? Sure hope you did. All right, let's go ahead. We're going to plug this x is negative 5 back into one of these equations and solve for x. Go ahead and do that, and let's see what you get. All right, I was able to squeeze that in there. I was able to get y as negative 3. So let's go ahead and write that at the bottom as our solution. Make sure you have them in the correct order. So we have our solution as negative 5, comma, forgot the negative, negative 3. Now again, you can check your answer to see if you got the correct answer as well. That's something that's always an option. So I'm going to go ahead and I'm going to give you an opportunity right now to try part B. Now, here's what I'm going to say. We practiced eliminating y here first. I want you to try practicing eliminating x. See what you can do with that, and let's see if we come up with the same answer. Go ahead and pause the video right here. All right, go ahead and check your answer with mine for part B. You should have ended up getting 2, -1 as your solution. Now, what's really funny is I always tell you to check your answer because, you know, you can make a simple mistake. I actually went back and looked at A, and I did everything so great up until this point. Did some of you notice that mistake? That's okay. Teachers make mistakes too. I realized this should have been a +3, so scratch that out. Scratch that out. This should have been a +3. Now, if I checked my work, I would have seen that, right? So this is a good reason why you show all your work here so that your teacher can follow it and see what you are doing. So I did that exact same here. I also went back and mentally checked, but it's good for you to physically write it down and check. So you're going to go ahead, and now your teacher's going to assign you your homework for tonight. So have fun mathing.